Did you ever hear about claims transformation in ASP.NET Core? It's an interesting approach to how you can extend the claims of the current user to implement a custom authorization policy, for example. In this video, I'm going to show you how to implement claims transformation and what are some caveats that you need to know about. Let's start with a quick explanation of claims transformation inside of ASP.NET Core. It's not uncommon that your system is going to contain a dedicated identity provider. An example of this could be Keycloak, which I use in my Clean Architecture and Modular Monolith Architecture courses. Another example could be using Active Directory or Azure Entra ID for authentication, and what all of these identity providers have in common is that you first need to authenticate with the identity provider, which is going to give you back an access token. And then you can use this access token to authenticate with your backend application. And how claims transformation fits into this picture is it's going to execute right before you authorize the user inside of your application. So as you can see here, in step number 1, we are authenticating with the identity provider, which gives us back the access token, and then we can call our backend with the access token provided. In step number 4, we're going to run the claims transformation to append additional claims to the existing one that we already got from the access token. After this step, we're going to authorize the user, and if they are authorized, we're going to execute the request and return back the API response. A few quick things you should know about claims transformation. It is executed on every API request. The operation itself should be idempotent because it can execute more than once for every API request, which would result in adding duplicate claims, and you want to avoid this. Because it's executing on every API request, the performance of the claims transformation operation is your responsibility, and you should consider introducing caching if you are doing some database calls, for example. The entry point for doing claims transformation is the iClaims_transformation interface, which only exposes one method called transformAsync. It gives us the current claims principal and allows us to modify it by introducing additional claims. I'm going to show you how to do this in the practical part of this video. We're going to start from an empty ASP.NET Core Web API, and our first step is going to be to implement JSON Web Token authentication. So let's go ahead and install a NuGet package, and I'm going to look for JWT Bearer. I'm going to install the latest version of Microsoft ASP.NET Core Authentication JWT Bearer, and with this NuGet package installed, I can go ahead and configure some services. So I'm going to say builder services add authorization to introduce authorization services, and then I will say builder services add authentication to introduce authentication services. Here I need to specify what is going to be the default authentication scheme, and I can use the JWT Bearer defaults class to specify the bearer scheme as the default authentication scheme. Then I'm also going to chain a call to add JWT Bearer, which is going to introduce some services from the NuGet package that we just installed. Then I'm going to introduce a simple API endpoint. This is going to be a GET endpoint, and the route is going to be /hello, and it's going to inject a claims principal instance and return the current user's name if it exists. I'm also requiring the user calling this endpoint should be authorized with a respective JSON Web Token. If I go ahead and start the API, which is now running in the background, I can go ahead and send a GET request to the /hello endpoint. And this is going to give me back a 401 unauthorized response because I don't have a valid access token. So let's go ahead and fix this. And what I'm going to do is use the user-json Web Tokens utility to create my JSON Web Token. I need to navigate to the root of my ASP.NET Core project and call the .NET user-jwts create command. This is going to scaffold some configuration inside of our project that I'm going to walk you through right now, but it's also going to give us a valid access token that we can use to authenticate with our API. So let me go ahead and copy this access token, and I'm going to specify it here. And if I restart my API and send this request again with the access token present, I expect this request to succeed, and you can see that we get back a 200 OK response, and it says hello Milan. So you can see that the name claim is also present on this JSON Web Token. Now let's go ahead and examine what happened behind the scenes when we executed the .NET user-jwts command. If I open up my application settings, you can see I now have an authentication section, which is configuring my JSON Web Token authentication, and it's specifying the valid audiences and the valid issuer for the bearer scheme. So the valid audiences are the localhost ports where my API is exposed, and the valid issuer is our command line utility. If you're wondering where it's getting these values from, it is accessing the launch settings JSON file where you're specifying your HTTP and HTTPS ports. It's also going to store your JSON Web Tokens locally using your user secrets, which is how you'll be able to reference them. And now let's spend a moment to examine the JSON Web Token that was generated from the command line utility. If I open up JWT IO and paste the access token value, you can see that this is indeed a valid access token. We can take a look at the payload, where we can see that the subclaim is Milan, which is actually the current user of my system. I can also specify a custom subclaim when calling my command line utility. You can see that the audience claim contains the URIs for our backend, and this JSON Web Token has a fairly long expiration time. You can see that it's set to August 18, which is 3 months from when I'm recording this video. So this is how we can generate a JSON Web Token that we can use for local development. And now let me show you how claims transformation fits into all of this. What I want to do is to create some helper classes, and I'm going to start with a static class called custom claims, where I'm going to define my subscription claim. Then I'm going to add an enum representing my free subscription levels. We have a standard subscription, a gold, and a platinum subscription. And then I'm going to define a simple service called user subscription provider that exposes one method accepting a user identifier, and based on the user identifier is going to return the user subscription level. Now you can imagine that this could call out to a third-party API or my local database and check what is the current subscription status for this user, and based on that is going to return the subscription value. But to make this example simpler, I'm just going to return some fixed values if the user ID is present or not. And then what I want to do is to use the user subscription provider to extend the claims of the current user. So I'm going to define a new type that's going to be called the custom claims transformation, and is going to implement the iClaims transformation interface from ASP.NET Core. As you can see, this exposes one method called transform async, and you can also use dependency injection for this type. I'm going to use it to resolve a service scope factory that I'm going to use to create a custom scope. Now let's see how we would implement the transform async method. I said that this should be idempotent, so we have to check the claims principal and see if it contains a specific claim. So I'm looking for a claim where the type is equal to custom claims subscription. If this is true, we can say return task from result and just return back the current claims principal. We don't need to change anything. Otherwise, I'm going to create a service scope using my service scope factory, and I'm going to use this scope to access the service provider and resolve my required service. And this is going to be the user subscription provider. So this is how you can get a scoped service inside of the custom claims transformation. Let's assign this to a variable, and then I'm going to use the subscription provider to get the user subscription, and I'm going to access the claims principal, access the identity, and provide the user's name. This is typically going to be the ID of the current user, but if this is coming from a different claim, then you can provide the value of that claim. This is going to give me my subscription, and then I need to extend the claims principal with an additional claim. How we can achieve this is by creating a new claims identity. Instead of mutating the claims principal, we create a new claims identity, and then I can add a claim on this claims identity. So I'm going to say new claim, and then specify my custom claim name, and I'm going to convert the subscription level into a string. And now I can add this identity to the original claims principal. So I can specify the identity, and this is going to extend the claims on the claims principal, which is going to now include our custom subscription claim. And all I have to do is just return this from this method by saying task from result, and we return the claims principal. As I said, this operation could be calling out to a third-party API or a database, so this is going to impact the performance on every API request, so it's recommended to introduce caching for this operation if it's going to be an expensive one. So this completes our claims transformation implementation. Now we need to register some services with dependency injection, and I'm going to register my user subscription provider as a scoped service, and then I'm going to register my claims transformation as a transient service. So I'm going to say iClaims transformation, and then specify my custom claims transformation as the implementation of that service. And then what I want to do is to define a custom authorization policy. So I'm going to provide a delegate to the add authorization method and call the add policy method. Let's call this policy premium user. and then I can configure my policy instance. So I'm going to say policy, and then I want to add my individual requirements. So let's say that this policy requires an authenticated user, and it also requires a specific claim. So I'm going to specify the claim name using my custom claims constant, and I will specify the subscription claim, and then I can pass in what are the allowed values for a premium user. So I can say subscription gold and toString because the claim values have to be strings, and I can also specify subscription platinum and then toString. So these are the two claims that I want to accept for a premium user, and now I can use my policy to authorize an API endpoint. And remember the difference between authentication and authorization. Authentication just tells us that the current user is somebody who is authenticated with our system. Authorization allows us to configure what the current user can do. So I'm going to add a new API endpoint called premium. It's going to just return a different string from the minimal API endpoint, but this time I'm going to require that the current user needs to satisfy the premium user policy. So with this in place, let's test out the custom claims transformation. My API is running behind the scenes, and I'm going to call the premium endpoint. We're going to hit the breakpoint inside of my custom claims transformation. We're going to hit the breakpoint inside of my custom claims transformation. And if I walk through this method, you will see that we are going to create a custom service scope, resolve the user subscription provider, and obtain the user subscription. Finally, we're going to add our custom claim, and we're going to complete this method. And if I hit continue, we will hit the breakpoint in my premium endpoint because we have satisfied the premium user policy. Let me press continue, and you will see back in the HTTP file that we get back a 200 OK response. Now I'm going to update my custom claims transformation, and I'm going to specify null when calling this method, and this is going to return the standard subscription level, which is going to cause us to fail our authorization policy. And if I send this request to my API, you will see that we get a 403 forbidden response because we didn't satisfy the premium user policy. So this is how you can use claim transformation to extend your user's claims and implement some additional authorization requirements in the backend without exposing additional user information as part of the claims inside of a JSON Web Token. A real-world use case for this feature would be implementing role-based access control, where the current user is authenticating with your API and you're storing the user's permissions inside of the database. Based on the user's identifier, you can extract what are the current permissions, add those as claims, and then use them to authorize the user with the respective API endpoints. Now let me show you what an implementation of this would look like. This is a claims transformation example from the project that we are building in my Modular Monolith course. You can check it out from the link that's going to be in the description of this video. Now let me walk you through the claims transformation process. I'm using a service scope to resolve a permission service, which is going to use the identity ID that's available as a claim on the JSON Web Token to resolve the current user's permissions. Then it's going to add these permissions as custom claims on the claims identity and add it to the original claims principal. Once we have those claims in place, we can implement the custom permission authorization handler, which is going to be very simple. It's just going to get the user's permissions from the user's claims, and if these permissions contain the required permission, we're going to succeed the authorization requirement. Otherwise, we're just going to return from this method, and it's going to cause a 403 forbidden response. And then let me show you an API endpoint to see how this is used. For example, the get order endpoint, we're just going to say require authorization, and we can specify our permission constant. In this case, the permission name is called get orders, and if this permission is present, then the current user is allowed to access this API endpoint. And if you want to see how to implement all of this from scratch, then I invite you to check out my Modular Monolith course. Let me know in the comments what you think about claims transformation in ASP.NET Core, and if you want to learn more about JSON Web Token authentication, then you should watch this video next. Check out my Clean Architecture and Modular Monolith courses from the video description, and until next time, stay awesome.